All right, let's talk about something that feels a little bit like magic. How do those drones, UAVs, stay so perfectly still in the air? It's an incredible high-speed balancing act that's happening completely unseen. So how do they pull it off? Let's dive in.
I mean, you've seen it, right? A quadcopter just hovering. It's almost like it's frozen in place, just defying gravity. But what's really going on behind that simple, quiet moment? Well, it turns out it's one of the single biggest challenges in modern robotics. You see that stillness? It isn't actually a state of rest at all. It's an illusion, and it's created by a constant, almost frantic battle. That drone is actively fighting against a dozen different forces that are all trying to knock it right out of the sky. We're talking thousands of corrections every single second.
So, when we talk about flight stability, here's what it really boils down to. It's a two-part job. First, the drone has to stick to its flight path, right? Maintain its course and its attitude. But second, and this is probably the harder part, it has to actively fight back against all the things trying to push it off that path.
So let's break down those forces. What exactly is a drone fighting against up there? Well, the threats, they come from all over, from both outside the machine and, believe it or not, from inside the machine itself.
Yeah, the most obvious enemy is the environment. Unpredictable gusts of wind that come out of nowhere, sudden changes in air pressure. These are constant chaotic forces that the drone's brain has to manage in real time just to keep from being tossed around.
But the trouble can also come from within. Just picture an agricultural drone that's dispensing seeds over a field. As it drops that payload, its own center of mass is constantly shifting. That tiny change in weight distribution has to be accounted for instantly, or the whole thing loses its balance.
And this one's kind of wild. A drone can actually be its own worst enemy. The very motors that are working so hard to keep it in the air create these high-frequency vibrations. And at the same time, the rotors are blasting a turbulent column of air downwards, the downwash, which can mess with its own flight path. It's literally fighting a battle that it started.
So you're faced with all this chaos, inside and out. How in the world do engineers build a stable drone? Well, they come at it from two different angles, using a toolkit that combines really intelligent software with some seriously smart physical design. You can pretty much think of it as the brains and the body. The brains, that's all the complex control algorithms that are running the show. And the body, that's the physical hardware, the drone itself, which is designed from the ground up to be naturally more stable. So let's look at the brains for a second. This isn't just one simple program, it is a whole suite of really clever strategies. You've got things like PID controllers, which are constantly asking, okay, where am I supposed to be, and how fast do I need to fix it? And you've even got advanced stuff like neural networks that can actually learn and adapt to conditions while they're flying.
And this quote right here just nails it. These control systems are basically the drone's central nervous system. They're like a superhuman pilot, taking in all this data from sensors, gyroscopes, accelerometers, and making thousands of microscopic adjustments to the motor speeds every single second to hold that perfect, steady hover. Now, on the physical side, the body, the innovations are just as impressive. We're talking about wings that can literally change their shape in the middle of a flight to adapt to the wind. We've got passive spring dampers that just absorb motor vibrations before they even become a problem. And we even have 3D printed frames that have been optimized by an algorithm for the best possible stability with the least amount of weight. And check this out. Here's a really fascinating detail from the research. Just look at the difference something as simple as propeller design can make. It turns out, studies show that a 3-blade propeller actually gives you the best balance of stability. It has the lowest deviation from a perfect hover, and it outperforms both 2-blade and 6-blade designs. Kind of counterintuitive, right?
Okay, so all of this brilliant engineering is cool, but why does it actually matter? What's the point? Well, because better stability isn't just some academic puzzle, it unlocks entirely new capabilities, and it makes autonomous flight safer and way more reliable for all of us.
A super stable drone can give you much clearer radar images for mapping. It can navigate through a crowded forest without crashing. It can drop a single seed in the exact right spot in a field, fly in perfect formation with a whole swarm of other drones, and even land safely on a moving ship or a rocky hillside. These are the kinds of things that are defining the future of what UAVs can do.
And the impact here can be absolutely massive. Get this, one study found that by just redesigning a payload system, they switched to a split tank to better balance the load, the engineers improved that UAV's flight stability by a staggering 80%. That is a gigantic leap forward from just one smart design change.
So this all leads to a really interesting question. As we get better and better at mastering the physics of stability, what's the next great challenge? What's the next big mountain to climb in autonomous aviation?
Well, the focus is starting to shift. The next frontier isn't just about keeping a drone steady during a normal flight. It's about making it resilient, able to handle things going wrong, like a sensor failure or a lost connection, and still continue its mission safely.
And that really brings us to the final thought here. As these machines start to operate more and more on their own, the core engineering problem starts to evolve. We're figuring out how to make them stable. The real question, the one we have to solve next, is how do we make them fundamentally trustworthy? Something to think about. Thanks for tuning in.